Hi everyone, my name is Amanda Zhu, and this is my teammate Yilian Jiang. And today we are going to do a time series analysis presentation. We are team number 2. And now I'm gonna start with the first time series analysis. Now let's scroll down to the second page and see the first graph. Okay, as you can see, the first time series graph represents the U.S. field production of crude oil in 1,000 barrels over the period from 1981 till the 2020s. And this graph shows a clear upward trend in the crude oil production from 1980 until the early 2000s. And it reached a peak in approximately 3 million barrels. And as you can see around early 2000s, there is a significant drop in production and falling below 500,000 barrels. And after this drop, and you can see the production remains relatively low, but starts to show a slight increase post 2010. And this graph also indicates a noticeable fluctuation up and down, especially before the sharp drop around 2010. This fluctuation suggests a seasonal pattern or cyclical behavior in the crude oil production, and which is typical in time series data. And in summary, for the first graph, the time series of U.S. crude oil production shows an initial upward trend with a significant fluctuation, and then a sharp decline in the early 2000s. And as you can see, a subsequent period of low but slightly increased production with the minor fluctuations. And so this analysis suggests the presence of both trend and seasonality components in the data. And now let's scroll down to the second analysis and see the one-year dynamics. And for this graph, it represents the monthly fuel production for crude oil in 1,000 barrels for year 1982. So as you can see in January, which is M1, the production starts at around 2,400,000 barrels. This is a very notable decline in production through the first half of the year. It reaches a decline in production through the first half of the year, reaching a very low point in about 1,600,000 barrels in June, which is M6. And move on to July, which is M7. There is a slight recovery, as you can see, which the production increased to around 1,800,000 barrels by August, which is M8. However, around September, it falling back to around 1,600,000 barrels. And starting in October, which is M10, the production begins to rise more steadily. And by December M12, it reaches about 2 million barrels, which is pretty much the similar levels starting at the beginning of the year. As a summary, as you can see, this one-year dynamic indicates a significant fluctuation in crude oil production with a clear seasonal pattern of decline in the first half of the year and followed by a gradual recovery in the latter half. That's pretty much the summary for the second part of this report. And now let's scroll down to the third part of this analysis report. And as you can see, this graph shows a U.S. Crude oil production by season, which highlighting the distinct peaks in the winter and summer months due to a pretty high demand. And there is a significant production spikes occur in, as you can see, both the January, which is the beginning of the year, and the December, which is the end of the year. While there is a February and a September, there is a notable fluctuation. I would guess it's likely due to operational factors. Overall, we can conclude that the production consistently exceeds the mean due to the peak seasons, with the regular dips and the recoveries indicating a routing maintenance and adjustment through the year. That's pretty much about the third part, and now let's move on to the descriptive statistics. There is a clear indicator on the graph about all the mean, median, maximum, and minimum. So I'm just gonna briefly go through everything. So this histogram shows a bimodal distribution with two prominent peaks. And the first peak, as you can see with the highest, occurs around the lower production levels, especially below the 100,000 barrels, indicating many instances of low production. And the second peak is more spread out and occurs between a 1,500,000 and 2,500,000 barrels, which suggests another common production range. And I'm going to quickly go over the statistical summary. As you can see, the mean is average monthly production is around 1 million barrels, and the median for the monthly production is something around 1,500,000 barrels. And which the maximum of this graph is around 3,500,000, and the minimum would be as low as 1 million and 1,010,000. Now let's go down to the fifth part, which is the ACF and the PACF part of this cologram. And the ACF basically shows a very high and slowly decreasing autocorrelation values, which indicating a strong persistency and a potential non-stationarity. This would suggest the underlying trends or seasonal patterns may be affecting the data. And the PACF, as you can see, it has a significant initial lag with sporadic, significant spikes at higher lags. And as you can see on the right side, there is a Q statistic values that are progressively increasing the consistency, which is 0 p-values. This means this recommend is strongly rejecting the null hypothesis of no autocorrelation and confirming there is a significant autocorrelation at numerous lags. And that's basically everything about ACF and PACF. And now let's move on to the sixth part, which is the unit road test. So as you can see, the first model is constant model, and the p-value is 0.611, which is much more than 0.05, which suggests us to fail to reject the null. And it means there exists for at least one unit root. So we now need to take the first difference. And as you can see, after taking the first difference, the p-value is pretty similar, is almost equal to 0, which is much smaller than 0.05, which means we have to reject the null and there's no second unit root. So as a conclusion, you can see for the first model, there is exactly only one unit root. And if we scroll down to the module 2 is constant and trend. And if we go down to module 3, and module 3 is none. So, but similarly, module 2 and module 3 all have the same conclusion as module 1. So as a conclusion for these 3 modules, we can see there is only one unit root for entire time series Y5. And that would conclude the first part of this presentation. And now I'm gonna give the microphone to my teammate Ilian Jiang, and she's gonna present the second part of this report.
Okay, as for my part, I will go to the forecasting. So at first, I divided the period on training. So I divided the training data from 1981 module 1 to 2022 module 12, and the testing data is the last 12 months from 2022 module 1 to 2022 module 12. So at first, I will find the top 20 ARIMA models based on AIC. So this is the graph of the result. So The models with the lowest AIC, BIC, and HQ values are considered the best in terms of balancing fit and complexity. So we can see the lowest AIC is the first one is the model 8 and 8. So it suggests that it might be the best model based on automatic selection. So let's move on to the results. So I use this top 10 best models to estimate their RMSE for the test period. So we can get result that the lowest one is the ARIMA 9 and 12. So because it has the lowest RMSE, so it indicates that it is the best performing model among the top 10 based on RMSE for the test period. So let's go to forecast. Since ARIMA 9 and 12 is the best, so it is the result of this. And we can get the graph. It shows that it is a relatively stable prediction with some uncertainty as indicated by the two standard error bands. And RMSE is around 44,000. And it indicates that the model's prediction are within 10% of the actual value on average. So we can get a conclusion that the ARIMA 9 and 12 model provides a solid forecast for US crude oil production. And within the error metrics and graphical representation supporting its reliability for the best period, for test period. So let's move on to the real-time forecast. Since we put the test period to 2023 module 1 to 2023 module 12. So it is the make a real forecast for 12 months after the last variable available data. So this is the result of this, and the ARIMA 912 model predicts a stable production level for US crude oil in 2023, with the forecast values remaining consistent around 400,000 barrels per month. However, the widening to standard error band suggests increasing uncertainty of time, highlighting the inherent unpredictability of long-term forecast. The model provides a reasonable estimate, but should be interpreted with caution due to the expanding range of potential outcomes as the forecast period progresses. So that's our team's presentation. Thanks everyone to give us our patience to listen it. So thanks everyone.
Thank you. If you have any questions, feel free to ask or comment. And thank you for listening.